Now the next topic is hyperbola. In the beginning of this chapter, we discussed that how to obtain hyperbola when a double napped right circular cone is intersected by a plane. Then we are getting union of two curves. Union of two curves, that is hyperbola. See, each one is obtained by intersection of a nap, from upper nap, from lower nap. So when double napped right circular cone is intersected by a plane, union of two curves is obtained, that is, it is hyperbola. Now, in the plane of hyperbola, there exist two fixed points. Let me say this point is F1, this point is F2. Such that if we take any point on this hyperbola and if you measure a distance, see this is F1P, this is F2P. This point is farther, this is closer. So longer distance minus shorter distance. Suppose that this is 12 and this is 5. So value is 12 minus 5, so 7. Now, as we change location of this point P, suppose this is a P2, this was P1. Now, P2, from P2, this distance, this is greater. This point is farther, this point is closer. This is closer. So, greater distance minus smaller distance. If suppose this is 10, then this will be 3. F2P minus F1P is 10 minus 3, that is 7. If suppose P point is on this branch, then this distance of P3 from this point, this is farther, this is closer. So greater minus smaller. So F3P minus F1P is greater minus F2P. This point is P3. This was for P2, this was for P1, this is for P3. So distance of a point from these two fixed points and its difference that is greater value minus smaller value. So if this is 11, this should be 4. So 11 minus 4, that is 7. So here the property is that select any point P either from this branch or from this branch. Measure its distance from two fixed points. Take difference, means greater distance minus smaller distance. It will be always constant. So this is true for every point of this hyperbola. So we can define this hyperbola by this way, that it is the set of all the points. Here hyperbola is set of all the points such that if we take any point P and measuring distance of this point from two fixed points, if this is F1P, this is F2P, then difference of these two distances is always constant. f1p minus f2p, it is always constant. So hyperbola is the set of points such that difference of distances of every point from two fixed points is constant. So here fixed points f1 and f2, f1 and f2 are said to be foci. Now words or terminology for hyperbola. In case of ellipse, we had words major axis, minor axis. Here words are different. See, to understand those words, I am taking here again a hyperbola. This is a hyperbola. These are fixed points f1, f2. Now, if I join these 2 points by a line, then this line, it is said to be transverse axis. So a line passing through foci, both foci, is said to be the transverse axis. Of this hyperbola. Now this line, if intersects curve in A and A dash, then length of A dash, length of this line segment is said to be length of transverse axis. So if transverse axis cuts hyperbola in points A and A dash, then length of line segment A dash is length of transverse axis. Here length of transverse axis is taken 2 times A. These are the symbols. Length of transverse axis is always we will take 2 times A. And midpoint of this transverse axis, midpoint of this line segment A dash, let me say this is O. It is the center of hyperbola. So this distance is A. This distance is A. So total is 2A. Now if we take a perpendicular line from center perpendicular to transverse axis, a line perpendicular to transverse axis and passing through center is said to be the conjugate axis. So this line is said to be conjugate axis, and the length of a conjugate axis is denoted as length of conjugate axis is denoted as 2 times b. So because length of a conjugate axis is denoted as 2 times b, here above this transverse axis and below this transverse axis there exist 2 points b and b dash, which are at distance b, small b. This distance will be b, b, b. This distance is a. One more point, distance between foci. It is taken as 2 times c. Distance between these two foci is taken 2 times c. Here in this diagram, here this is f2, this is f1. This distance is c, this distance is c. So distance of every focus from center is taken c. Hence distance between these two foci is 2 times c. Distance of every focus from center is taken c. So that's why distance between foci is 2 times c. Here A and A dash are vertices. Intersection point of transverse axis. Intersection point of transverse axis with hyperbola are said to be vertices. So here A and A dash are vertices. Here A and A dash are vertices of hyperbola. Or we can say ends of transverse axis. A and A dash are vertices of hyperbola, and each vertex is at distance a from center. Each vertex is at a distance a from center. So these are symbols and words which we are using in this topic. Then eccentricity. Here also eccentricity is E is equal to C by A. Same words. This is ratio of distances. What is C? It is the distance of any focus from center, and this is distance of any vertex from center. So definition is same which it was in ellipse. So here E is C by A, and say in case of hyperbola, value of E, this ratio will be always more than 1. it will be always more than 1, because here, as we discussed, in case of hyperbola, this is center, this is foci, here vertex. So this distance of focus is C, this distance is C, distance from center to focus is C, and distance of vertex is denoted as A, and you can see that this is greater, this point is further than this point. C is greater, A is smaller. So C by A, this ratio will be always greater than 1. In case of ellipse, eccentricity is always smaller than 1. In case of hyperbola, eccentricity is always more than 1. Now standard equations. See, first equation is first type is, if suppose hyperbola transverse axis is along x-axis, that means hyperbola is such that transverse axis is along x-axis, and from center this is conjugate axis. If transverse axis is along x-axis, then its equation is x square upon a square plus minus, here minus comes, y square upon b square equal to 1. X square upon a square minus y square upon b square is 1. If transverse axis is along x-axis, keep a square below x square and x square term positive, y square term negative. Transverse axis is along x-axis, then keep remember the number below x square, call it as a square. Y square keep a negative, because here conjugate axis is along y axis. Now this point is A, this point is A dash, this is focus F1, this is focus F2. We know that focus is at a distance C, so coordinates of focus C0, here minus C0. Coordinates of A, this is at a distance A, so this will be A0, this will be minus A0. These are vertices. Here B is 0B, B dash is 0 minus B. So length of a transverse axis is 2A, length of conjugate axis is 2B, foci are C0 minus C0. Eccentricity is C by A. So whenever such equation is given, always draw graph by this method, show values by this method. But if equation is, suppose y square by a square minus x square by b square is 1, x square term is negative. If x square term is negative, y square is positive, then the number below positive number consider as a square. If equation is of this pattern in which x square is negative, then denominator of y square we are saying a square. So here sketch of this hyperbola will be, transverse axis will be along y-axis. Here union of two curves. So in this case curve will be like this. This is center, this is A, this is A dash. See below y square, this is A square. So take a coordinates of A, 0A, here 0 minus A. These are vertices. Then foci, here F1, 0C, here 0 minus C. Below x square this is B square, so put here B, 0B, B dash, 0 minus B. So these are foci. Foci lie on y-axis, vertices lie on y-axis. So in this case vertices are A0 and minus A0. Foci are plus minus C0. Here vertices are zero A, 0 minus A, and foci are 0 plus minus C. In both the cases, length of transverse axis is 2A, length of conjugate axis is 2B, length of, in both cases, length of transverse axis always we will take 2 times A. This is 2 times A. Here this is 2 times A. Length of conjugate axis always we will take 2 times B. Relation between A, B and C. A is a semi-transverse axis, this is semi-conjugate axis. So relation between A, B and C is, here C square is equal to A square plus B square. C is square root of A square plus B square. In case of ellipse, we were taking C square equal to A square minus B square. And here we are taking C square is equal to A square plus B square. Eccentricity, E is C by A, that means C can be also taken as A into E. So foci we can also take as plus minus E 0 if E is given. If eccentricity is given, foci can also be calculated by this formula. Now in these equations, if A square equal to B square, either in this equation or in this equation, if A square equal to B square, then this equation 1, it will be converted into 1 and 2. Both equations, equation 1 and equation 2 will be of the form, putting here B square equal to A square, so x square by A square minus y square by A square is 1. So this will be x square minus y square equal to A square, and If you put here a square, b square equal to a square. If you keep here a square, so y square by a square minus x square by a square is 1. Then shift a square on this side. So equation will be y square minus x square equal to a square. So these are said to be equilateral hyperbola. So this hyperbola is said to be equilateral hyperbola. If a square is b square, then hyperbola is equilateral hyperbola. So these are properties of hyperbola. Find the coordinates of the foci and the vertices, eccentricity and the length of latus rectum of the hyperbola. See here, observe this equation. X square is a positive and minus sign is assigned with y square. This is 1. So it is of the form x square by a square minus y square by b square is 1. So it's a sketch of this hyperbola. It will be something like this. Its transverse axis will be along x axis. If x term is positive, x square is positive, then its transverse axis lies along x axis and conjugate axis along y axis. See, look in this equation. This is not standard form. To be equation in standard form, here there must be 1 and coefficient of x square and y square must be 1, 1. So to convert this in standard form, here we divide by 784. So 49y square upon 784 minus 16x square upon 784 is 1. That is, now simplifying this, 784 divided by 49. Say 49, 784, 7 into 7, 49, 112 into 7 is 784. Then 7 into 1, 7, 7, 6, 42. So this is 1 by 16. So this is y square by 16 minus x square upon, similarly dividing by 16 to 1, 784, this will be 49. It is equal to 1. Here it is clear that 49 into 16 is 784. So see, here y square by a square minus x square by b square equal to 1 form is obtained. In this equation, y square term is positive, minus sign is with x square. RHS must be 1. When observing sign, here there must be plus 1. So x square is negative, y square is positive. So this number we are taking a square. This number we are taking b square. Here x square is positive. So this number is 16 is a square and 9 is b square. So always keep remember, when y term is positive, then its sketch will be something like this. As discussed in theory part, every such hyperbola in which y square is positive, its transverse axis lie along y axis. Transverse axis lie along y axis and conjugate axis along x axis. So sketch of this equation will be something like this, and sketch of this equation, this curve will be like this. A square 16, B square 9. Now C square is A square plus B square. That is C is equal to C square is equal to A square is 256. A square already given 16, B square is 9, 25. So C square is 25, so C is 5. Here in this discussion we have taken C, distance of a focus from center. So that's why we take a positive value. C is 5. Now, so coordinates of foci, therefore coordinates of foci are, because here transverse axis lie along x axis, here there are foci. So their coordinates will be plus minus C0. So plus minus 50. Vertices, this will be vertices A dash. So vertices will be A0 minus A0. So vertices are plus minus A0. So that is plus minus A is 4, 40. A square is 16, so A is 4. So these are vertices. And eccentricity, E is C upon A. C is 5, C is 5, A is 4. So eccentricity is 5 by 4. This will be always greater than 1. Length of latus rectum. Length of latus rectum. Length of latus rectum. Formula is same which was in ellipse. Length of latus rectum of hyperbola is 2b square by a. Same formula was in ellipse. Here we are getting latus rectum, means a line segment which is perpendicular to transverse axis passing from focus whose ends lie on hyperbola. So this is latus rectum. Similarly here also we are getting latus rectum. So 2b square by a. So 2 into b square is 9. A is 4. A square is 16. So A is 4. So this is 9 by 2. We can also calculate length of transverse axis, length of conjugate axis, length of transverse axis. Length of transverse axis is 2 times A. This length, this is 2 times A. 2 times A, that is 2 times 4. So it is 8. Length of conjugate axis. Length of conjugate axis is 2 times B. B is 3. So 2 into 3 is 6. This side, this is the sketch. Here foci lie on y-axis, vertices lie on y-axis. So their y coordinate will be 0. Sorry, their x coordinate will be 0. Here this will be 0a, this will be 0 minus a. Foci 0c, this will be 0 minus c. So according to these results, now we calculate value of a c. A square is 16, so A is 4. B square is 49, B is 7. Now C square is A square plus B square. So C square is, or we can also put like this, C is root A square plus B square. You can also put by this way. C is root A square plus B square. So that is square root of A square is 16, B square is 49. So this is square root of 50 is 65. So C is root 65. So foci are 0 plus minus C, because transverse axis lie along y axis. So 0 plus minus root 65. So that is foci. Vertices, here vertices are 0 plus minus A, these are vertices. A is 4, so 0 plus minus 4. Then eccentricity, E is formula C by A. C is root 65, A is 4, so eccentricity is root 65 by 4. Length of latus rectum, is 2b square by A. Here b square is 49 and A is 4. So this is 49 by 2. So say, remember, in case of hyperbola, which value we are taking? A square. For A square, observe positive term. Y square is positive, take this number A square. Here x square is positive, this number as A square. In case of ellipse, greater value we were taking A square. Here don't take from greater or smaller, take from positive or negative. So this is the method, application of formula to find values. Find equation of hyperbola satisfying conditions. We take one by one these questions. We want equation of hyperbola whose vertices are plus minus 2 0, foci plus minus 3 0. Say here vertices and foci lie on x-axis. Vertices and foci lie on x-axis. Therefore, equation of hyperbola will be x square upon a square minus y square upon b square is 1. This will be the pattern of equation. Say here vertices and foci lie on y-axis. Vertices lie on y-axis or foci lie on y-axis. So its equation will be of the form y square upon a square minus x square upon b square equal to 1. So remember the difference in pattern of equation. X square is positive, so put a square. Here y square is positive, below y square put a square. Now vertices plus minus 2 0, see here vertices, that is plus minus a 0, so this is plus minus a 0, so it is plus minus 2 0. And foci plus minus c 0, its value is given plus minus 3 0. This is plus minus c 0, this is plus minus a 0. So here a is 2 and c is 3. So a square is 4 and c square is 9. Now we know that c square is a square plus b square. So therefore 9 is equal to, c square is 9, a square is 4, b square is required, so b square is 5. So a square is obtained, b square is obtained using this result. So equation of hyperbola is Putting value in this equation, x square by a square minus y square by b square equal to 1. Here vertices lie on y-axis. So 0 plus minus a is 0 plus minus 3. Foci on y-axis. So 0 plus minus c. Foci on y-axis, it is 0 plus minus 5. So by comparison, E is 3 and C is 5. So A square is 9, C square is 25. Now again we use this result. C square is A square plus B square. So 25 is 9 plus B square. So B square is 16. So A square is 9, B square is 16. These values now we are putting in equation. So required equation is y square upon A square minus x square upon B square equal to 1. In this question, see, foci lie on x-axis. Foci lie on, it lie on y-axis. Foci lies on y-axis. So its equation will be, equation of hyperbola will be, if a foci lie on y-axis, then put y square first, positive. Y square by a square minus x square by b square equal to 1. Now see what is given here. Foci, that is 0 plus minus c. This is 0 plus minus c is 0 plus minus 13, and conjugate axis, length of conjugate axis, that is 2b. Length of transverse axis, that is 2a. Here length of conjugate axis is 2a, it is 24. Length of conjugate axis is, formula is 2b. So 2b is 24. Length of transverse axis 2a, length of conjugate axis 2b. Here conjugate axis given, so we take 2b. So here C is 13 and B is 12. This is formula for length of conjugate axis. So therefore C square is 169, B square is 144. Now to find A square, we take C square equal to A square plus B square. That is 169 is A square plus 144. So A square is 25. A square is obtained, B square is derived, and from A square and B square, putting value in this equation, so required equation is y square upon A square, y square upon A square minus x square upon B square, x square upon B square equal to 1. So this is the required equation of hyperbola. So consider or determine equation from given values, whether vertices or foci lie on x-axis or y-axis. Now we want equation of hyperbola whose vertices are plus minus 7, 0 and eccentricity is 4 by 3. Say here vertices lie on x-axis. Vertices lie on x-axis. So its equation will be x square upon A square minus y square upon B square is 1. And here these are vertices So we are given plus minus A0 is plus minus 70 and eccentricity is 4 by 3. Vertices, so take A0. Therefore, E is 7 and E. Now formula for E is C by A. C by A is 4 by 3. To find equation of hyperbola, we require A square and B square. A square we know, A square is 49, but to find B square, we have to use the formula, put E equal to C by A. Now this value we are taking here. So C by 7 is 4 by 3. Therefore, C is 28 upon 3. C is obtained. A is obtained. We can calculate now B. So to calculate B from C and A, we use result C square is A square plus B square. C square is 28 by 3. Square of this number is 784 upon 9. 28 square 784 by 9 equal to A square is 49 plus B square. Then B square is 784 by 9 minus 49. So B square is, LCM is 9, 784 minus, now 49 into 9, 450 minus 9, 9 into 9, 81, put here 1, then 8 is left, 9 into 4, 36, 36 plus 8, 44, so 441. 49 into 9 is 441. 360 plus 81, so 441. That is B square is, now 784 minus 441, 4 minus 1 is 3, 8 minus 4 is 4, 7 minus 4 is 3, 343 by 9. This is B square. Now using these values, putting in this equation, so required equation is x square upon A square. What is A square? A square is now 49. A square is 49 because A is 7 minus y square upon B square. B square is 343 by 9 equal to 1. So therefore x square by 49 minus 9y square by 343 equal to 1. So this is a required equation. Then we can also simplify this by taking here LCM, but keep as it is allowed. X square by 49 minus 9y square by 343 equal to 1. Or because if we take LCM 49 into 7, so this can also be simplified more. One more step here, 343. If you multiply by 343, then 49 into 7. 49 into 7, so 7x square minus 9y square equal to 343. This equation can also be written in this form. Now here, foci lie on x-axis. So required equation, Because foci lie on x-axis, required equation is x square by a square minus y square by b square is 1. Given that here plus minus c0 is plus minus 40, foci, that is plus minus c0, and length of latus rectum, that is 2 times b square by a, is 12. So here c is 4 and here b square is, taking multiplying a on this side, b square is 6a. Now we solve this value. We want value of a and b to substitute in this equation. So now we are coming on this relation. C square is a square plus b square. C square is 16. A square keep as it is. B square is 6a. So we are getting equation, quadratic equation in A. Say C square is 16, A square keep as it is, B square is 6a. So it is A square plus 6a minus 16 is 0. So it is A plus 8, A minus 2 is 0. So A is minus 8 or A is 2. But keep remember, here A is length of semi, 2a is length of, there are two axes, transverse axis, conjugate axis. 2 times a is length of transverse axis. So this is length of half transverse axis, semi transverse axis. But it cannot be negative. This is not possible. E we have taken for length, half of transverse axis, or it is distance of any vertex from center. A is distance of any vertex from center. It cannot be negative. This is possible. A equal to 2 is possible value. So A square is 4. Now using this value A equal to 2 here, from b square equal to 6a, b square is 6 into a already derived here 2. So b square is 12. So a square is 4, b square is 12. Putting in this equation, so required equation is x square upon a square is 4 minus y square upon b square is 12 equal to 1. This can also be expressed as 3x square minus y square is 12. Now before explaining this question, I discuss two properties. We already discussed a property of ellipse, that for any ellipse, this is any ellipse, these are two fixed points f1 and f2, which we say foci. P is any point, variable point. For any point P on this ellipse, f1p plus f2p, it is always constant, and this is always equal to length of major axis. For any point P on ellipse, distance of P from foci are f1p and f2p. Sum of this distance is always constant, and that constant value is 2 times a. This is length of major axis. So this property we are going to use in this question. Now look here, there is man running a race course. Suppose that this is a race course ground. Man is running a race course. He notes that sum of the distances from the two flag posts. Suppose these are two flag posts, F1, F2. This is the location of man. Sum of distances from two flag posts, F1P, F2P. F1P plus F2P. This is sum of distances from two flag posts. P is location of man. This is constant. It is 10 meter. This is 10 meter. It is given. Now, by this property, sum of this distance is always 2 times 8 length of a major axis. This is length of a major axis. This length we know that it is 2 times A. So here this is 2 times A. So this sum of distance is 2 times A is 10. So value of A is 5. So A square is 25. We are also given that distance between flag post is 8 meter. Here distance between flag post is 8 meter. This is 8 meter. So this is nothing but sum of foci. This is distance between foci, and we know that distance between foci is 2 times C. Here there is a center. So this distance is 2 times C, that we know. Distance between two foci is 2 times C. So 2 times C is 8. So C is 4. C is 4, so C square is 16. Now property of ellipse, that C square is A square minus B square. We are taking here major axis along x axis. So C square is A square minus B square. So A square will be below x square. So C square is 16, A square is 25 minus B square. So B square is 9. A square is 25, B square is 9. So required equation of this posts traced by man means equation of path. So required equation of the post traced by the man, it is x square by A square plus y square by b square is 1. That means nothing but equation of ellipse whose major axis lie along x axis. So x square upon A square is 25, y square upon b square is 9 equal to 1. We also discussed a property of hyperbola. We also discussed, see, there is similar property in case of hyperbola, that if this is hyperbola, this is conjugate axis, transverse axis, here vertices, here distance between these points. Here this distance is 2a. Distance between these 2 points was 2 times a. Here distance between these 2 points is 2 times a. this distance is 2 times a, that is length of a transverse axis. Now if a P is any point, on this hyperbola, these are foci f1, f2, then distance of P from f1, distance of P from f2, these are distance. As P changes its location, this distances will be changed, but difference of this distances remains constant. So here greater, this is greater, distance of P from f2 is greater minus distance of P from f1 is smaller. Greater minus smaller is constant and it is 2 times a. Here length of a transverse axis. Here among these two numbers, whatever is greater keep first, smaller keep second. If Pf1 is greater, put here Pf1, then subtract Pf2. So this was property of hyperbola. So let me insert one statement. For any point P on hyperbola, this is the property.